Good morning, US. Good morning, California, and good evening, India, and good evening, Kerala. That too, good evening, Cochin. So, welcome to the Global Electronics Weekly Talk Show with me, that is your host Rajiv Kulkarni, and we have this every single Friday. We try to have this now every single Friday because we are talking about global electronics manufacturing and the challenges and the impact of electronics manufacturing globally, and how what are the challenges we face in the electronics manufacturing, and what kind of remedies, what kind of solutions exist there. It's basically a knowledge sharing platform, I would say. And I will be interviewing a lot of different professionals from this electronics manufacturing industry, so that everybody share their knowledge, everybody can share their company's details, and so that people will get to know each other in this small electronics manufacturing community. Welcome to the show. And today we have a special guest. Before we go to the guest, I would like to show you a brief video on this today's topic. So let's have a look at the video, and then we'll go to the guest details.
Quality in all delivery processes. Infrastructure and equipment second to none among EMS and ODM companies. SFO's coveted position as the partner of choice from major original equipment manufacturers is surely the outcome of their relentless efforts, overcoming the challenges posed by these key differentiating factors. Renowned customers trusted them for product engineering services like the DFM, DFT, DFA, industrial designs, firmware and application development, besides partnering for outsourcing their manufacturing requirements, whether in electronics, plastics, sheet metal, tool design, machining, magnetics, cable and wire harness, optronics, latching relays, or high-level assembly. The global manufacturing facilities of SFO, at Kochi, Bangalore, Mysore, and Pune, are equipped with state-of-the-art manufacturing equipment and test facilities that enable building components and products meeting stringent quality standards specified for mission-critical applications by industries like healthcare, communications, defense and aerospace, industrial, energy, and transportation sectors. SFO is known for their rare passion to excel every time they engage with any of the global customers. A separate FOD area for defense and aerospace customers, enhancements made in the cable and wire harness plant, a new world-class latching relays plant, and capacity additions at the mechanical, plastics, and machining plants, are some of the recent strategic moves at SFO. Dedicated high-volume manufacturing is another hallmark of SFO's recent focus. This ultra-modern plant at the Nest Electronics City houses two high-volume manufacturing plants with 15 SMT lines, and associated equipment, enhanced with trending technologies. SFO is currently developing the electrical power management system for the 5th generation, twin-engine, stealth fighter aircraft and the twin turboprop-based light transport aircraft, slated to be certified as a 19-seater passenger airliner of India. These include the LRUs for the AC Primary Power Management Unit, Regulated Transformer Rectifier Unit, and the DC Power Management Unit. Creation of Nest Digital, the software engineering domain provides a big leap of diversification at SFO. Augmented with healthcare, automotive, digital and GIS platforms, artificial intelligence, machine learning, cybersecurity, mobility, cloud technologies, IoT and analytics competency, Nest Digital brings in great value additions for SFO's global customers. Well placed, SFO is marching ahead to become a $1 billion conglomerate, sooner than the expectations of our stakeholders.
Welcome back to Global Electronics this morning from the United States, and evening in the Asian countries, I would say, especially in India. And before the start of the program, I mentioned good evening Kerala, good evening India, and good evening Cochin. Yes, that is the place where this particular company is situated, and that is the place where we have the guest from today, Mr. Anilraj Radhakrishna. He is from SFO Technologies. He serves the company as assistant general manager, and he is highly technically driven individual and a professional nature. He is an engineer himself, so he will talk with him about the topic, the BGA and the importance of BGA in the modern electronics, that is in the electronics manufacturing, and also about the soldering, that is reflow soldering, and the importance of BGA soldering. We are going to touch that topic today with Mr. Anil Raj. Welcome to the show, Mr. Anil Raj. Good evening to you. How are you this evening?
Yeah, good morning. Good morning. I am doing good. And good morning and good evening to all. So, myself,
Thank you. Thank you.
as Mr. Raju said, myself, Anil Raj, heading Process and Equipment Engineering Division at SFO Technology. So, SFO
Very
operates
nice.
under the Nest Group, a company based in the southern region of India. So, Raju, thank you for giving me this opportunity to speak on the topic of the reflow sorting process and be a different BGS
Absolutely.
sorting techniques.
Absolutely, sir. Absolutely. First of all, thank you for you. Thanks to you because you took out some time to join this call and share your wealth of knowledge. Excuse me. Share your wealth of knowledge with all our audience out there. And also, I would like to
Right.
thank the supporters and thank the audience as well that you are logging in to learn your knowledge as well. You are free to write anything on the comment section, on the YouTube comment section in the link, about the BGA and the reflow soldering that we are going to discuss. If you have any questions, definitely you can. And because I already have some questions which has been sent by some audience when we shared the link. So basically, Global Electronics is trying to bring the professionals from the electronics manufacturing so that we can address on a day-to-day basis all the challenges. So first of all, as we have pointed out in our topic in the poster, can you brief on BGA, varieties of BGA and importance of BGA in modern electronics, Anil Raj?
Yes, definitely, I can. So, as you know that it's a name itself, the BGA. BGA stands for the B ball grid array. So, it's a type of surface mount package used in the integrated circuits. So the BJ packages are widely used in modern electronics due to their compact in size and high density of connections, and it has excellent thermal and electrical performance. So normally in the BJ, I can share one, details I
Yes,
can share.
I
Okay,
have given you the sharing permission,
please
and
share that
you
so
can
that what
try.
I can do is I can share my screen also. I can
Screen.
share that so that you can get some details related to the BGA. And you hope
Absolutely.
you can see that, right?
Right now, let me see. I don't know if
Yeah, yeah, yeah. This
yeah,
this
yeah.
this is a this is a BGA actually. If you see this BGA, this there are ball which is beneath the component. So that, pardon?
Anil Raj, make it full screen. Your presentation. Put it in the presentation mode so that.
Yeah, yeah. This is the ball grid array where you can see that it's a laminate. Below that, the
Yeah.
solder ball is attached to that. So here there are die which is mainly for so many interconnections. That die is mounted over the laminate and over which the wire bonding is done to the substrate. So the beauty of this particular construction is that the die can be directly soldered to the PCB so that the electrical transferring can be done it better. Why? Because so it is directly connected to the PCB instead of the normal lead and all. the beauty of this BGA when we connect to this to the PCB surfaces.
Okay, excellent,
And,
excellent. And
if
what
we
are the
go
so go ahead.
Yeah, if you go to the BGA construction process, then these are the different steps of manufacturing process for the BGA. So normally the dies, there are so many interconnections in the die where all the circuits are connected together. Then that circuit is mounted on the substrate, and the wire attachment that will be done through the wire bonding process. Then the entire package will be molded. Then after that, that will be some certain balls will be mounted on the substrate. Then that will be sent through the reflow and for the proper bonding of the bolts into the BGA. So then the electrical test will be done. Then that will be inspected and that will be packed in a normal tape and reel form. That is a normal construction of this particular BGA. If you look into the different type of BGA, there are wide variety of BGA available in the market now. Some cases, I can say that some of them are ceramic type BGA and some of them are plastic type BGA. There are so many BGAs like thin film BGA, micro BGA, and ultra thin film BGAs are available in the market. So why we are using this particular BGA means, so nowadays all the circuitry, because you know that for the mobile phones, the size of the mobile phone is too small, where we can get so many applications in that, right? So the
Correct.
miniaturization of the electronic circuit is done through this particular complex circuitry called the that's why in the modern electronics, most of the circuits are converted from the traditional normal fine pitch IC into the ball grid arrays.
Okay, very interesting. So, what are the normal challenges in the BGA soldering? Because when you mention the BGAs, the balls, right, they need to be soldered, if I understand
Right.
that correctly. Yes.
Yeah.
So,
Yeah. So I said that the BGA is mainly, you know, that BGA means there is a solder ball beneath the
yeah,
substrate. You know this, right? So
correct.
then it has its own disadvantage, like the challenges may be in the case, it requires if you do the inspection on the BGA. Once the BGA is soldered, then the visual inspection cannot be possible. And this
Okay.
can be done only through latest equipment called X-ray or AXA or MXA, that type of equipment. Then one of the critical point I can here say that the alignment of the BGA, if you say the BGA, then there are so many so many balls on this, because nowadays the ultra thin film BGA having the pitch, it is only 0.3 mm. Then that type of BGA properly aligned to the PCB before the soldering process. That is one of the challenges. But that can be mitigated through the latest pick and place equipment available in the market. And second point is, as I said earlier, there is a hidden connection on this because the BJ balls are beneath the package. So the visual inspection is impossible. So normally, so the de-wetting issues or the voids in the BGA is very difficult to detect that. That is one of the challenge which we can see it in the BGA process. Then the thermal profile. So as I mentioned earlier, the thermal profile is so critical in this particular process. Why? Because achieving a correct reflow soldering temperature for uniform solder joint formation is a challenging job for the BGA process. The impact is if the solder joint doesn't get a proper reflow soldering temperature, that can damage the component, while insufficient heat can lead to a cold solder joint also. Then earlier said that there is a critical defect which is there in the BGA is the void. Void is mainly because of the oxidation of the ball, solder ball, or maybe due to the entrapped flux or entrapped air in the BGA ball. So excess voids lead to thermal and electrical performance. This is one of the defect, which we can see that. Then the PCB, again, the PCB warpage, there will be, because based on the thermal profile, if we are not setting the thermal profile properly, then there will be a PCB warpage. And nowadays, for the critical products, the one of the requirement is the cleanliness on the PCB or the PWA. So if you mount the BJ, it's very difficult to clean the underneath of the BJ. Why? Because normal cleaning process is not suited for that. But the latest so many equipments like saponifer cleaning or the vapor phase cleaning is available in the process control. For the process control that can be used for this particular process to remove the complete flux from the BGA. So another critical challenge which we have seen is the repair and rework of the BGA. So once if there is any voice on the BGA or if there is any deviating on the BGA, it's very difficult to rework on that. So that will damage the PCB or the BGA itself. Sometimes if there is any bridging on the BGA, then that cannot be removed as normally if you do it for the other components. Then there is one of the another challenge is the thermal expansion mismatch. So differing the coefficient of thermal expansion between the PCB and BGA. If the thermal expansion is different, then that will lead to the stress to the solder joint, and that can lead to the crack on the board. We do the thermal cycling or the ESS test on that. Then the PCB design is very critical. There are the different method of PCBA designs for this BGA. So that is again very critical for this. Normally, all the BGAs are moisture sensitive devices. The moisture sensitive devices means which absorb the moisture when we expose that particular part into the normal atmospheric conditions. So that may lead to the delamination of the BGA or popcorning effect when we do the soldering process. But that again can be mitigated through the different technology. It is available now, like it can be kept inside the dry chamber or that type of different process control is available in the market. So these are the different challenges when we go to a BGS soldering on the particular product. Hope it is clear on this.
Fantastic. Yes, yes, yes. You have explained it very nicely, Mr. Anilraj. Let's take a quick break here and we'll come back again.
Okay, right.
Good morning, good afternoon, good evening to all the audience of Global Electronics who's watching right now this show, which is a very interesting topic we have chosen about the BGA and the reflow soldering of BGA. And Mr. Anil Raj Radhakrishna from SFO Technologies, which is located in the southern state of India called Kerala. And to be specific, they're based out in Cochin city. And they have multiple locations in India. They're one of the largest contract manufacturing company based out in India, serving multiple market segments, aerospace, aviation, defense, automotive electronics, medical electronics, and consumer as well as industrial electronics. So we are discussing with Mr. Anil Raj about the BGA, and he explained it very nicely about the challenges that is being faced today in BGA soldering. And he also mentioned that there are a lot of techniques are available to find to face this solution? Welcome back to the show, Mr. Anilraj, after this small break. So now the
Okay.
next question I have is the different types of pads that are used in BGA and which one is better?
Yeah, yeah, I got it. I got it. That's an interesting question. So, different type of BGA parts are defined. Most of them are defined by the BGA manufacturer itself. But there are two primary type of parts used in the BGA footprints. One is the solder mask defined part, and it can call it as SMT, and other is the non-solder mask defined part is NSMT. So, so in SMT part, the name itself suggests that the solder mask defines the footprint of the BGA. This a layer of solder mask partially cover the underlying copper part, leaving a
Okay.
small opening for the solder mask. That's called the SMD part. But it has so many advantages, like it enables the precise soldering due to the reduced copper size. Since the copper part size is too small, so that the precise soldering can be done it with that. And the solder mask overlay reinforces the connection between the part and the circuit board. So that reduces the risk of delamination caused by the thermal or the mechanical stress, because that overlay will lead to a protection cover for the circuit part on this. That's the benefit of using the SMD part. Coming to NSMD part, that is no solder mask defined part, that is differ from SMD by leaving a gap between the copper part and the solder mask, thereby exposing the entire part. So here for the NSMD, the part is completely exposed one. So it has the benefit, like offers superior solder adhesion due to full part contact with the solder board. So that is the advantage of this particular NSMD part. Then the solder ball is able to make a connection to the entire NSMD part instead of the mask defined portion of the SMD parts. So it will properly give a better contact to the footprint. So again, this NSMD part can be smaller than the diameter of the solder ball. As I said that, 0.3 mm diameter for the smallest BGA, then the SMD parts can be smaller than that particular diameter. Typically, this reduction in part size is 20% smaller than the ball diameter. So the part size can be made 20% smaller than the ball diameter. That will reduce so that since the part size is reduced, there's an additional room between the adjacent part that allows for easier trace routing. Because as I said that the BJ is used in the complex circuitry, then we need to have a
Correct.
proper trace between the two footprints. Because that can be done with the NSMD part. So this can almost become a necessity when the routing a high density or fine pitch BGA for the latest complex project. But this particular NSMD part has a disadvantage. These parts are prone to delamination from the PCB under mechanical and thermal stress. That's one of the disadvantage of this NSMD part. So that, but if you take into account, so we need to use the NSMD part style wherever possible due to its improved sortability and pad accuracy. So the pad accuracy is better in the NSMD part. So it is better to use NSMD part for normal BGA designs and all.
Okay.
That is
Excellent.
so.
Excellent.
I can share one presentation. So I will
Yes,
share
please.
one presentation on this how the parts are defined for the BGA. That also I can show it now. There's a small
Yeah, that was
presentation
my
I
next
have.
that was my
Yeah,
next question actually, how the pad design is defined for
exactly right.
BGA
So that
and any.
I can show some presentation on that. I think
Please.
it is clear now, right?
Yeah, I still show the BGA construction process slide.
Is it okay now?
Stop. Okay, okay. Okay, okay, understood.
You can see that, right?
One second, let me reshare the screen to you. Okay, yeah, yeah. Less pitch
Yes,
component
yes,
footprint.
correct. Yeah, correct.
Okay, okay.
Hope it can be seen, right? Yeah.
Yes, yes, yes,
So
we can see.
this is if you see this, this is the one of the complex PJ which is assembled in our manufacturing facility. If you see this, there are the gap between the two solder ball is 7 mils. This is called as 7 mils. So that these are the critical BJs where the ball size the pitch is 15 or 16 mils. The mils is 1/1000 of an inch. So that 16 mil pitch BGA where we can get 7.8 mil gap. So as I said, for getting a better routing, that's a trace routing process. We need to maintain this particular gap, which is close to 8 mil or something. We need to do that. So this is uh, So this is another footprint connection. So I can show it now. Having if you look into the BGA, there are the number of balls is more than 3,600 numbers here. So this is another product which is assembled in our facility, having multiple BGAs, and where so the number of soda balls are more, and the pitch and the ball dia is way too small over here. So these are the different type of BGA package which is used in the manufacturing area. And again, there's an advanced version of the BGA is package on package. So it's the BGA can be mounted over another BGA. That is, you can see it in the presentation. The below one, which is the BGA over the BGA over that, the BGA, multiple BGAs are stacked together. So here again, as I said earlier, the interconnection between the two components is through the solder balls, so that the electrical resistance, the resistance or the inductance between the two components due to the absence of the trace can be done it here, which increase the speed of the signals through the two different BGAs. So this
Okay,
is mainly used where the high-speed applications are required. Base one is a processor and the 2 point is a DDR. So these are the different type of BJ construction. And this is the one which I have explained earlier, the solder mask defined part and the non-solder mask defined part.
yeah.
So here, the part is properly defined this. And if you look into this, these are the different type of ball diameter which is available for the BGA in the market. And these are the right side is the pitch of the component. Then if you look into the part dimensions, then when we do a proper design of the BGA parts, then there will be a, as I said earlier, there will be a 20% reduction can be done from the BGA ball diameter. So if you look into the 0.75 BGA, the 25% reduction on the BGA ball diameter can be given, which can lead to a 0.5 line diameter. Similarly, for 0.6 25% reduction can be done. For the smallest BGA, 0.15 BGA, 15% reduction can be done, and we can maintain a land diameter of 0.1 So these are the different part dimensions that is available in the market, and these are the basic construction or the design guidelines for the properly defining the footprint for the BGS.
Excellent. So, what is the importance of stencil design in the BGA soldering?
Yes. So about your point here.
Yeah, I mean, you
So the
can definitely
stencil,
share any slide. Yeah.
yeah, I can share one more slide here on the stencil design.
Yeah, yeah, I can. Yeah, you can take a. Yep, welcome
Yeah.
back to Global Electronics and Anil Raj. We have today with us, and we are talking about the BGA and reflow soldering. So, yes, Anil Raj, welcome back.
Yeah. So this is regarding the stencil design. Yes.
Stencil
So
design, yes.
yeah. So many micro BGA, as I said earlier, that so many micro BGA and the CSP having the pitch close to 3 mm, that is close to 12 mil, is there in the product. In this case, the stencil design is very critical. Why? Because the stencil design is crucial because the BGA soldering, it is directly impact on the accuracy and the quality of the soldering process. So a well-defined stencil, I can say that a well-defined stencil ensure the proper amount of solder paste is applied to the BJ part, that helping to prevent the issues such as the bridging and insufficient solder or the misalignment of the BJ on this. So there is a guideline, IPC guideline, that is 7525. That is mainly for the stencil design process, which specifies two critical parameters for the stencil design. And one is the area ratio and other one is an aspect ratio. So a generally accepted design guideline for the acceptable paste release is an area ratio greater than 0.66 and aspect ratio that is greater than 1.5. So that's why the BGA, for the BGA, the stencil design is very critical. And this aspect ratio and the area ratio is directly linked to the stencil thickness. So the stencil thickness is designed or defined based on the smallest component footprint on the product. So if you take a small BGA or thin film BGA, then definitely uh, that footprint need to be taken for defining the stencil thickness. So normally a rounded score apartheid design is ideal for BGA because as it enlarges the solder paste deposit and it increases the area ratio and adds solder paste volume to the corners of the rounded land part. So this type of design ensures sufficient paste distribution without narrowing the gap between the land parts when if we consider the smallest BG and all. That's why the 7525 standard, IPC standard specifies so many guidelines for the stencil design. It's a vast subject. The stencil design is
Yes,
again is
yes. No, that's fine. That's a very good, very well explained. And
that's
I
the,
have one
that's
more
the
question.
yeah.
Yeah. I have one more question on the what is this reflow soldering and why is it important for BGA soldering?
Yeah, why? Because the reflow.
I mean, of
So,
course, again, sorry to interrupt. Again, of course, reflow soldering also a long, it's a vast subject, but
yes, correct,
you can
correct.
mention it in a very brief manner because we are talking more on the BGA soldering.
All
So,
right, all right,
why
right.
it is? Yeah, yeah.
Yeah, because the process of normally the reflow sorting is mainly for the proper soldering of the BGA bolts, right?
Hmm.
So
Yeah.
nowadays, so many BGA bolts are available in the market, tin lead alloys such as 6337, 6040, and its melting temperature is 183 degrees Celsius. And SAC 305, that is a lead-free BGS, its melting point is 27 degrees Celsius. But to get a proper wetting of the BGA balls onto the PW or the product or the PCB, So then there should be a 30 to 40 degree. We need to maintain a 30 to 40 degree above the melting point of this particular alloys. That's why, so we need to set up a thermal profile to get the proper weighting of the BGA balls to the PCB. That's why this thermal profile is very, very critical. And the optimization of the critical machine parameter to suit the product complexity, that is known as the profile qualification. So the thermal profile qualification depends on so many factors, such as as I said, the component density, the type of the solder paste, the PCB thickness, the layer count, or the copper foil thickness. So many factors are depends on the thermal profile qualification. Nowadays, leaded BGAs are lead-free BGAs are
Lead
soldered on
free.
the leaded product. It's called backward compatible process. So the backward
Yeah.
compatible thermal profile also be selected for this particular applications.
Very
So
nice. Very nice.
for developing a thermal profile, there are so many factors need to be considered. So since as I said, it's a vast subject. There's no time to go in detail into the reflow process parameters. I
Yeah.
can show some of the profile that is used in the manufacturing process. I can show that.
Sure. So in the meantime, the audience, if you are watching, please do subscribe to the channel so that we can bring more and more such topics to you, and you will have an advantage to watch our show and definitely learn more and more on the electronics manufacturing. Thank you. Yeah.
So this is
Yes.
the
Please go ahead,
yeah.
Mr.
So
Anilraj.
yeah. So for the better thermal profiling, the BGA, so the thermocouple need to be attached properly to the BGA to get a proper temperature measurement. And these are the specifications. There's, as I said earlier, 7525 standard IPC. There's a standard 7530 that is mainly for the profile qualification. And there are various parameters that need to be set in the thermal profile. And these various parameters can be set uh, by controlling the two main parameters in the equipment, that is the conveyor speed and the zone temperature. By controlling the temperature and the zone temperature or on the conveyor speed, we can achieve this particular specification. If you look into this, 7530 standard says for tilted alloy and mixed backward compatible alloy, lead-free alloy. There will be a alloy which is small, mainly for the backward compatible process. So this is one of the thermal profile. I can say that there are multiple stages for the thermal profile called ramp rate, the soak time, then the rate of rise, then the peak temperature, the time boil liquidus, and the cooling rate. And there are so many critical parameters. And this particular thermal analysis done by attaching the thermocouple on the BGA. And then there are so many thermal profilers are available in the market to properly analyze the thermal distribution on the BGA. If the thermal distribution is not proper, then definitely there will be a head and payload effect and voids in the BGA. There are different type of defects can occur if we are not defining the thermal profile properly on the BGA side.
Excellent, excellent. So, last couple of questions, quick questions I would like to address. What are the main inspection methods for BGA solder joints?
Okay,
That is
so
one question.
yes, that is one of the challenge on the BGS soldering. But for this, either there are so many X-ray equipments, X-ray machines are available,
Yeah.
and manual X-ray machines and automated X-ray equipments. It's called AXI is available in the market, and Using that, we can do the inspection of BGA solder joints. So nowadays there are stringent requirement for the solder joint quality. Like IPC says the void should not exceed 30%. But for the customers like aerospace and defense customers, they will say that they have their own standard. They said the void should not exceed 10%. So for this also latest technology is available, the vacuum reflow soldering. The so many new technology is implemented, that is mainly to reduce the voids in the PGS solder board. That is the vacuum reflow soldering process. So the during the peak reflow soldering time, the air which is entrapped inside the solder ball will be removed by the vacuum process. It is available in the market now.
Excellent, excellent. So the last question is, can BGS can be reworked?
Yes, I can say that BGA means that is again depends on some requirement, like the BGA can be removed and replaced with a new one, and the
Okay,
BGA reballing is also
okay,
can be done with for this there is a specific automatic BGA rework station, and the micro stencils are available to do the rework
okay.
on the BGA that can be done it.
Excellent. I think we are almost over the time, Mr. Anil Raj, sir, and it is I mean, whatever you could share the knowledge in this short period of time, I think definitely I understand. All people have been showing a lot of support here. I've seen, the audience are showing it's too good, excellent, and they have been committing. And is there any standard to know reverse compatibility of BGA? There's a question.
Yes, that's why I said that the backward compatible process. I said that right. So the
Okay.
leaded BGA, that is the lead-free BGA can be soldered in the leaded process. This is a backward compatible. Then certain customers are defined like so many backward compatible process like a SNPB, SNPB plus, SNPB plus plus. Like there are so many different techniques are available. So it's basically to maintain the thermal profile to a certain value to
Uh-huh.
achieve the
Uh-huh.
better solder joint quality for the BGA. It can be done.
Okay.
That can be done.
Okay, great, great. I think the audience who asked, hopefully you got the answer. And so, is there any message you would like to convey to our audience, Mr. Anil Raj, before we end the show for
Yes,
today?
the main point which the BGA is, as you know, that the BGA and nowadays LGA, the micro BGA, these are the critical components which is used in the electronic manufacturing industry. Definitely, the stencil design and the thermal profile. If you fine tune and if you maintain a process control in that particular area, like, for example, like if you do the CPCPK study in the thermal profiling area, then definitely we can maintain a stable quality level in the BGS sorting process. That is, so need to ensure that we are maintaining the proper control in stencil, screen printing, and the reflow sorting process. That's all from
Excellent.
right.
Excellent, Mr. Anil Raj Radhakrishna from SFO Technologies. He is the Assistant General Manager from SFO Technologies, which is based in the southern state of India called Kerala, and the city they are based is Cochin. And SFO Technologies is a contract manufacturing and also complete turnkey solution company for the electronics industries, catering to aerospace, aviation, defense, medical, automotive, and industrial electronics, consumer electronics, and you name the market segment, they definitely are there to help and support your needs. today we had an excellent conversation with Mr. Anilraj Radhakrishna about the BGA and reflow soldering. And as he did mention, it is a vast subject and there are hundreds of questions all exist, but nothing to be worried. I will bring him again down the road, sometime after a few more weeks to talk about some other topics in the electronics manufacturing. Electronics manufacturing sounds very easy, but it is not. I mean, we have absolutely every step there are a lot of challenges. Every design has a challenge, every component has a challenge, so every processes has a challenge. So we are here, Global Electronics is trying to bring the electronics community together so that we can address these issues. So I would request the audience to subscribe to the channel so that we can bring more and more intelligent people like Mr. Anil Raj so that they can share their wealth of knowledge. Sir, thank you so very much for your valued contribution for this talk show and also sharing your wealth of knowledge. I definitely would like to bring you again on other topics, and if you would like to also bring your colleagues, that is more, you are more than welcome. Absolutely. So with that said, your host, your RJ or Rajiv Kulkarni will sign off one more episode of Global Electronics Talk Show. Wherever you are, be safe and be healthy and keep smiling. That's the secret of healthy living. Thank you very much.
Thank you. Thank you all. Thank you. Bye.